Hello everyone, so in this video we are going to solve a question of LeetCode, that is first and last position of element in sorted array. So let's start with the problem statement. Given an array of integer nums sorted in non-descending order, find the starting and ending position of a given target value. If target is not found in the array, return -1 and -1. You must write an algorithm with figure of log of n runtime complexity. So basically in this question we have given an array of integers and a value of target, and we need to find out the first and the last occurrence of this target, right? So let's quickly see the first example. So in the first example we have given this array and we need to find out the target is equal to 8, right? We need to find out this target. So if we carefully observe the first example, we can easily see this. The first occurrence is here, right? And the last occurrence is here. So if we write down the indexes of this, so this is the 0th index, this is the first one, this is the second, this is the third, this is the fourth, and this is the fifth, right? So we need to return 3 comma 4 from here, right? So this is the vector we need to run from here. Now let's see how can we approach this problem. So there are multiple approaches to solve this question. So the very first and the brute force approach to solve this question is through linear search. So in the linear search, what we do, we start from the left side and we check for the each element, right? We initially take two variables. First, let's say first is the first one and the second one is the last one, and we initially store -1 and -1 in both the variables, right? Because we need to return a vector of -1 and -1 if we couldn't find the element in the array, right? So we will initially store -1 and -1 in first and last. Now what we do, we start iterating from this array, right? So whenever we find out the first occurrence of this t, we will store this into the first variable. So we will store this into the first variable and we will also update the last one simultaneously, right? So 3 is also stored in this last one, right? Now we don't need to touch this first one, right? It is fixed. Now we will just continue our iteration and we will get this one, right? We will get 4. So this left is this last one is now updated with 4, right? Now we get this 5, right? This 5 is not equal to, right, this fifth index is not equal to this target, so we don't need to update this and our iteration is completed. So at the end we will just return a vector of f comma l, right? We will just return f comma l, that is 3 comma 4, right? So I hope this brute force approach is clear to you. This is a brute force approach and the time complexity is linear, that is big O of n, right? Because we are just iterating through all the n elements, right? Now since we have given, we need to optimize this approach to log of n, right? So whenever we see this array and this array is also sorted, so the very first approach which comes to our mind is the binary search, right? So let's quickly see how can we implement binary search here. Right, since the array is already sorted, so we can easily implement a binary search here. But since we need to find out the first and last occurrence, so we just need to update few statements in the binary search and we can easily find out the answer through a binary search. Let's see how can we do this. So let's say we will be making a function of a custom function, or we can say any of the function which will be in which we will be declaring a binary search algorithm, and we will be calling that functions two times. First time we will be calling for the first element and second time we will be calling that function for the last element, right? So let's see how can we do this. So whenever we will call for the first one, let's say first call for the first one, so what we do in the binary search, we take two pointers. Let's say the first pointer is on the leftmost side and the second pointer is on the rightmost side, right? And we find out the middle point here, right? So the middle point is 5 plus 0 divided by 2 is equal to 2.5. 2.5 is nearly equal to 2 in the integer value, so midpoint will come here, right? Now we will check whether this middle point's value is equal to target or not. No, it's not equal to target, but it is less than target, right? It is less than target. So definitely this value is present on the right side because the array is already sorted. So we will just update our middle point with L plus 1, or we can say L is updated with m plus 1. So this L will come here now, right? L will come here. Now L is here, and we will again check for the middle point for this, right? So the middle point for this is 5 plus 3 is equal to 8. 8 divided by 2 is equal to 4. So middle point is somewhat here, right? Now again we will check with the target. So the target is equal to 8, right? The target is equal to 8, and this value is also equal to 8. So this is equal, right? This is equal. So we will just store this into a variable. Let's say we store this into a variable x, right? X is storing the index 4, right? This is storing the index 4. Now what we do, since we need to find out a first occurrence, so first occurrence must be on the leftmost side. So what we will do, we will just decrement this r, right? We will not exit from this, right? We will continue our binary search, and we will just update this r with m minus 1, right? We will just update our r with m minus 1. So this r will come here, right? This r will come here. Now L and R on the same position, and middle will also be here, right? Because 3 plus 3 is equal to 6. 6 divided by 2 is equal to 3. So all L, R and M are on the same point, right? These are on the same point, and since middle is here on the third index and it is equal to the target, so we will just update X with 3, right? And after this r will again move to the left side, but it is going out of the bond because this r is less than L, right? Or we can say L is greater than R in the next iteration. So we will just stop our loop here, and for the left position we got our index is equal to 3, right? So what we did is, for the first occurrence we just updated R with m minus 1 whenever the element of the array, right, whenever a of m is equal to target, right? Whenever it is equal to target, we just update it with r is equal to m minus 1, right? So for this first we got our index is equal to 3, right? Now let's find out for the last index. So for the last index, each time we just initially store minus 1, right? Because it is already mentioned in the question that if it is not found in the array, we will return minus 1 here. So let's find out for the last element. So initially let's again keep L and R here, right? And let's find out the middle one. So middle one will be here. Now let's check this is lesser than the target. So let's update L here, right? This is equal to m plus 1. Now let's find out the middle point again. Middle will be here. This is equal to the target. So let's update X with 4, right? Now for the first occurrence, what we did is we updated R with m minus 1, right? Because we already know, right, the first occurrence must be on the left side. But for the last occurrence is always on the right side. So for searching on the right side, we will just update L here, right? So for this, L is updated with m plus 1, right? M plus 1. So let's say we update m plus 1 here. So this L will come to m plus 1, that is here, right? And R was already here, and L will also come here, right? Now we will check for the middle one. So middle one will also be here, right? Because 5 plus 5 divided by 2 is also equal to 5. So we will check with the target. So target is not equal to, right, the target is less than 10. So this will be just written from here, and we will just update this, right? This will be returned. So 4 will be basically written from here, right? So this is fine and this is fine. So at the end we will just return a pair of 3 comma 4 as a vector, right? So I hope the binary search is clear to you. We are just using two modification here. R is equal to m minus 1 and L is equal to m plus 1, right? And we are just doing these operations when a of m is equal to target, right? So I hope the approach is clear to you. If you still have any doubt in this approach, feel free to comment it down. Let's quickly move to the coding part. So in the coding, let's return a pair of the function which we will be create. So let's say we create a binary search function, and here we will pass nums target and um, character for telling whether it is the first one or the last one, right? So let's pass a character. Let's say first we pass for first, and the second would be binary search of nums target and the last one, right? So this we will be returning from here, and let's initialize this function here, right? So let's initialize the function here. So int binary search vector of integers nums and int target, right? Now what we do, we first take a variable int. Let's take a temporary variable which will be storing the value of the index. So let's take int x is equal to -1 initially, right? And let's run a while loop until l is less than equal to r, and let's initialize the initial value of l and r. So l is equal to 0 and r is equal to nums dot size -1, right? So now let's run the while loop and first calculate the middle point. So int m is equal to l plus r divided by 2, and now let's check if nums of m is equal to this target. Then what we will do, we'll just update this x index with m, right? We'll just update this x with m, and the next operation, right? The next operation will be based on the character which we just passed from here. So this will also be taking a character here. So character, let's call it character c, right? So if c is equal to f, it means it is our first occurrence. So for this we will be updating, right? We will be updating r with m minus 1. So let's update r with m minus 1. Else in the other condition, what we will do, we will just update l with m plus 1, right? So I hope this statement is clear to you. This is basically defining us whether we need to choose the left side or the right side. And else, let's check if nums of m, right? If nums of m is greater than target, if the current element is greater than target, then definitely the element must be present on the left side. So let's update r with m minus 1. Else the element must be on the right side. So let's update l with m plus 1, right? And at the end just return x from here, because x is basically storing the index. And this is it, I guess. Let's quickly try to run this on the sample test cases. Yeah, it's working fine. So let's just submit this. Yeah, it's running fine. So let's talk about the time and space complexity of the solution. So the time complexity of the solution is bigger of log of n, and the space complexity is bigger of 1, right? So the time complexity is log of n because we are using a binary search here, and the time complexity of binary search is log of n, and the space complexity is big of n because we are not using any array or anything. We are just using constant spaces here, right? So I hope the approach and solution is clear to you. If you still have any doubt in this question, feel free to comment it down. Please like this video and subscribe to our channel. I will see you in the next video.